So this video is going to look into the rules for filling orbitals with electrons, now that we know about the different energy levels and the different orbitals. So to help with this, you're going to be using the periodic table. So always when it comes to filling electrons and drawing out the different ways of filling electrons into orbitals, you're going to want to have access to your periodic table. So make sure you're using the full periodic table, either that you can see in your classroom or on your screen, or the full one in your data booklet. Make sure it is the full one, not the one that has the noble gases missing. Now in the periodic table, you can see that this periodic table has been color-coded into different groups. So we have in green what we call the S block. Now this is called the S block because the electrons within these elements, their outermost electrons, what we would call their valence electrons, are found in an s orbital. This is very obvious for hydrogen and helium. They are the only elements with a principal quantum number of 1. So all the electrons have an angular momentum of 0, so they're in an s orbital. But then when we go down every single period, as we start each period, we always start with an s orbital. So that is why all the elements in group 1 and 2, and helium, which can be considered a group 2 element, all are S block elements. The next block we have is the P block, and that's on the right hand side. So right after the transition metals. Now if we look at the P block, we can see that the P block is 6 elements across. Now P orbitals, we always have 3 P orbitals. If every orbital can only hold 2 electrons, that gives us a total of 6 electrons that can go into P orbitals. So that's why the P block is 6 elements across. And as, for example, you go from boron to carbon to nitrogen, oxygen, fluorine, neon, what's happening is that you're starting to fill and complete those P orbitals. Now, as we get further down, the next block which we're introduced to is the one shown in orange, which is the D block. And the D block is where you find the valence or the outer electrons for transition metals. And you can see that the D block, if you count how many elements across it goes 10 elements across. And that's because we have 5 d orbitals. Each d orbital can hold 2 electrons. And that gives us a grand total of 10. So as you go across the d block, what you're doing is slowly filling a d orbital with the outermost electrons. Now, every element that you've got fills every orbital up to where the last electrons are. So for example, zinc. Zinc is element 30. It is the very right-hand element in the D block for that first orange row. It will have filled the s orbital that hydrogen and helium have, the s orbital that lithium and beryllium have, the 3 p orbitals from boron to neon, the s orbitals from sodium and magnesium, the p orbitals from aluminium to argon, the s orbital for potassium and calcium, and then the d orbital. And so the electrons fill in that order. We also have the F block, which you don't need to worry about. I've just shown you that the F block is there, and if you count across it, it is 14 elements across because there are 7 F orbitals. So you should be aware of these blocks because you could be asked to identify where the outermost electron is in a given element, or be shown an outline of the periodic table with one section shaded in and asked what block is this. So you do need to know this. Now, once you are aware and know these blocks, you can start talking about filling electrons, and there are going to be filling orbitals, with electrons. There are going to be 3 rules for how orbitals get filled. So the blocks tell you where the outermost electrons are. Group 1 and 2, s orbitals. Group 3 to 8, the p orbitals. Your transition metals, your d orbitals. and the orbitals are filled in the order in which they appear in the periodic table. And so the order goes 1s, 2s, 2p. Remember that the number at start, that's the principal quantum number that's just telling you what period it is usually. And this is the way that it goes. Now, the unusual thing we see is that it goes 4s, 3d, 4p. Now, that is because the d orbitals, the first set of d orbitals we come to, are from principal quantum number 3. So even though it appears in the fourth period, it is the orbitals from the third principal quantum number, which is kind of confusing. You can see that it gets more confusing as you go along, but what I've highlighted in that rectangle is as far as you're ever going to need to go at advanced higher. So just remember that it goes 4s, 3d, 4p. The reason for this is because the orbitals have different energy values, and as they're going up in energy, we get this pattern. So we can see the 1s is the lowest energy. Then we've got the 2s and the 2p, which are low, but slightly higher. Then we've got our 3s and our 3p, and our 3d shown in yellow. Now, what we have between our 3p and our 3d is our 4s orbital shown in green. So the 3d and the 4s orbital are actually really close in energy. So sometimes you may see it represented with the 3d coming before the 4s. In most cases, you will see the 4s coming before the 3d. This will be important when we start looking at transition metals, because you can get a little bit of choice of electrons deciding which one of those to go into. But the orbitals are always increasing in energy. So the s orbitals of higher energy levels overlap with p and d orbitals of lower energy levels. So we can see that with our 4s and our 3d and our 5s and our 4d on this diagram. Orbitals that have the same energy value, like the 3p orbitals, are degenerate, and that word's going to be important because there's going to be a rule for degenerate orbitals. Now, when it comes to filling orbitals, we've got 3 rules. The first one is the Aufbau principle. And the Aufbau principle is that orbitals are filled with electrons in order of increasing energy, basically following the sequence from the periodic table. Essentially, you must complete a level, you must fill an orbital, all the orbitals of one level before you can move upward. If it helps, Aufbau is A, then B, which shows that you must go in ascending order to help you remember that the Aufbau principle is the one about the sequence, going in ascending order. And remember that order again is 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. However, you may sometimes see the 3d and the 4s switched around. That's not an error, it's not wrong, it's just sometimes they are drawn one way or the other. The second rule is known as Hund's rule. Now, Hund's rule deals with orbitals that are degenerate. And remember, degenerate means having the same energy value. So, for example, at any given principal quantum number, the 3p orbitals you have and the 5d orbitals all have the same energy, so they are degenerate. Now, Hund's rule states that degenerate orbitals are filled singly by electrons before they pair up. So if you've got the 3p orbitals, you put one electron in one p orbital, the next electron goes into a different p orbital rather than creating a pair in the first one. So you have one electron in each of the 3p orbitals before you then pair up. It's essentially like on a bus. If you're getting on the bus, you're typically looking for the empty seat that no one's already sat at, and it's only when you're forced to, because all the seats have someone sitting at them, do you choose to sit beside someone else. The third rule is known as the Pauli exclusion principle, and you actually already know this one. Now, the Pauli exclusion principle is that principle that we say no two electrons can have the same 4 quantum numbers. So essentially what this means is that when electrons are paired, Within an orbital, they must have opposite spins. Remember, one of them is going to have a quantum number plus a half, the other one's going to have negative a half. We show this using arrows. So we show one as an arrow pointing upwards, one as an arrow pointing downwards if we're drawing a diagram for this. Usually we do upward arrows first, and then we start pairing them with downwards arrows. And you're allowed to use double or single-headed arrows. Now those three rules, you're going to need to know the definition of them. You're going to need to remember which one is which, so which name represents which rule, and you're going to need to apply them. You're also going to need to remember what the different blocks on the periodic table are and how you can use the periodic table to work out which orbitals get filled in which order.